This video is about special products. So one special product is a binomial that is raised to a power. For instance, x plus 3, and then that whole quantity is squared. Since the square is right next to the parentheses, it means that everything in the parentheses is being squared. So what that really means is you're taking x plus 3 and you're multiplying it again by x plus 3. So you could expand it by writing it like this. These are equivalent statements. So x plus 3 raised to the second power is the same thing as x plus 3 times x plus 3. So one way that we could multiply this out is just to use the double distribution method that you learned about in the previous video. So you're going to multiply the two x's together to get x squared. X times 3 will give you 3x. 3 times x will give you 3x, and then 3 times 3 will give you 9. Your middle terms are your like terms, so you will combine those, and you'll have x squared plus 6x plus 9. Now let's take a look to see if we can see a pattern. So we know we have x plus 3 squared is x squared plus 6x plus 9. If we look at x plus 4 squared, that will give us x squared plus 8x plus 16. X plus 5 squared will give us x squared plus 10x plus 25. And 6 plus x squared will give us x squared plus 12x plus 36. So if you look at these carefully, you can see a pattern emerging. So the middle term on each one of these, you can see, is going to be the same thing as multiplying these two together and then multiply it by 2. So 3x times 2 will give you 6x. 4x times 2 will give you 8x. 5x times 2 will give you 10x. And 6x times 2 will give you 12x. You also notice there's a relationship between the 3 and the 9. 3 squared is 9. 4 squared is 16. 5 squared is 25, and 6 squared is 36. So you can see that if you have any binomial that is squared, it's always going to be the first term squared. Then the middle term is going to be by multiplying these two together and multiplying it by 2. And then the last term will just be this one squared. So if we use that pattern to expand this binomial, we know that a, in this case, this a here equals 2x, and b, this b here is really equal to 5. So if we plug those into this expansion, we know that a squared would be the quantity of 2x squared. Remember, you have to square the whole quantity. Then we have to multiply the a and the b together and multiply it by 2. So that would be 2 times 2x plus 5, times 5. And then the last one would be take the b and square it, so that would be 5 squared. If we do the math out, you'd get 4x squared plus 20x plus 25. Now, to be honest with you, it's really up to you whether you prefer to just expand the 2x plus 5 to 2x plus 5, 2x plus 5, and then do your double distribution, or if you're better at remembering the pattern and using the pattern. Whichever way is better for you. There's another product that is important to know, and that's when you're multiplying conjugates. And if you remember from a previous video, a conjugate is when you have the same thing in each parentheses, but one has a plus sign and one has a minus sign. So this x plus 3 times x minus 3 is an example of a conjugate. And when you multiply conjugates, it becomes the difference of perfect squares. So let's see how that works. So let's see what happens when we multiply these together. Let's use our double distributing method to multiply this out. So I'll multiply x times x to get x squared, x times negative 3 to get negative 3x, 3 times x to get positive 3x, and 3 times negative 3 to get a negative 9. Now my middle terms actually add to 0, so I have x squared minus 9. This product is called the difference of two squares because this first term is a perfect square, right? X times x is x squared. And this 9 is a perfect square. 3 times 3 is 9. And there is a subtraction sign in between. So that's why it's called the difference of two squares. So we can use our pattern to multiply this out. So we know the pattern is if I have a plus b times a minus b, I'm going to get a squared minus b squared. In this case, my a is x and my b would be 7. If I plug that into my pattern, I know that it's going to be x squared minus 49. So once again, you could still do this out by double distributing if you have trouble remembering the pattern. But this is kind of a handy pattern because it's easy to recognize, and it's a very simple short pattern to remember. It'll also help you when we work backwards and we start factoring.